There's a lot of talk right now about software factories, agents that build and ship software with less of you in the loop. Say that phrase to 5 different engineers and you might get 5 different definitions on what it is. Let me show you what one actually looks like and how to build it yourself using Mastra. I'm Damian. I've spent over 15 years as a software engineer, and these days I share what I'm learning building with AI right here on this channel. Software factories work because they let agents pick up real operational load, but you have to be deliberate about what you hand off and how much human review it still needs. This is going to be the first video in a series where we gradually expand what our factory handles on its own. This week, we'll take the same Dependabot Triage workflow that I covered in my Codex automations video, and instead of using Codex, we're going to use a Mastra agent to do the work instead. So before we get started, I want to thank Mastra for sponsoring this video. Mastra is a TypeScript framework for building AI applications and agents. I'll leave a link in the description if you want to learn more. The source for this software factory will also be available on GitHub, also linked below. Follow along and give it a try. So first, let's take a look at what the factory is going to look like as we build it out. To get started, we're going to need a few different pieces. Now, one, we're going to need a GitHub application that we can install into our GitHub repos for this to work. This GitHub application is going to be used to set up webhooks so that we can get notified when new pull requests are open on our repo. Those will notify our agent when it's a Dependabot PR to go ahead and do its analysis via a Mastra workflow. In addition to the GitHub application, we're also going to need a Slack application. For my purposes, I like to interface with my agents via Slack. That's where we're going to have it post any updates about Dependabot PRs so that we can be informed about what's happening, as well as the state of things. We're going to use Mastra's channels support to be able to set this up. In the GitHub repo, there's a manifest.yaml file for the Slack application that you will define the permissions that you need as part of it. So you can walk through there and set that up yourself. With all that in place, we're going to have a workflow that looks like this. First, Dependabot will open a PR. That will trigger a webhook to our application. We're going to go ahead and intake that, verifying the signature of the webhook from GitHub and make sure that it's coming from the source itself. Once that happens, we'll trigger a Mastra workflow. Here, we're going to have a triage agent that will go ahead and analyze the PR. We're going to give the agent a few tools. One will be a tool to actually fetch the GitHub pull request itself, as well as the changelog for the dependency. Once it's determined a verdict as to whether it can be merged or held or needs investigation, we're going to go ahead and move to stage 2, which is the delivery phase. Here we'll use Mastra channels to be able to notify us in Slack about the update. So here, what's going to happen is we're going to create a new Slack thread. And some of those pieces will be very important because the benefit of here is that each dependency update will be its own thread in Slack. We'll also be using Mastra memory so that we can interface and communicate with that thread, and it will have conversational memory about what we've been discussing. This will include a recommendation card as to what we can do. Let's take a closer look at the workflow itself. The workflow is going to be the heart of the actual triage system itself. So like I mentioned, the workflow will get invoked as part of the webhook that comes in. To start, we're going to create a new memory thread, allowing us to combine a thread ID, which is made up of the triage, a run ID, and isolate it from every different PR that comes in, so that we can have an independent conversation and have conversational memory differently per PR. From there, we're going to have our triage agent running and using the get-dependency-PR tool. This tool will fetch the dependency PR from GitHub and extract its details so we can understand what the change is. Next, we have a get-release-notes tool. In my case, the application I've been using this in is a Ruby application. So from here, we're going to connect to the RubyGems API to fetch the changelog for that dependency itself. Next, we'll generate a verdict and analyze the risk class as well as citation and reasoning behind the decision. Then we'll have some deterministic checks to enforce some citation rules to make sure that the LLM doesn't make an incorrect call. Once that's done, we'll move to step 2 in the workflow, which is where we'll resolve the Slack channels, render a Slack card so that we can have a nice UI as part of the message, and send it to a Slack thread. So now that we understand what we're going to build, let's take a closer look at the actual code. So if you pull down this repo, you can look at the .m.example file, which will outline the various pieces that you need to be able to get started. So in this case, I'm using OpenAI for my model provider. And so you'll need to provide an OpenAI API key. Of course, you can use any model that Mastra provides, and you can find all the details about that inside the Mastra docs. So you can use things like Anthropic or things like that instead if that's what you want to do. Next, we need a GitHub app. Once you have that, you're going to need that GitHub app ID and provide it in your .env. The GitHub private key is going to be needed as well to interface with it. From there, we also need a GitHub webhook secret. You'll need to generate this as part of your GitHub application and provide it here as well in the GitHub UI. Then from there, once you've installed the application, you're going to have a GitHub installation ID. You can grab this from the URL as well. Next, for Slack, we're going to need a Slack bot token, a Slack channel ID, and a Slack app token. For the purposes of this software factory, we're going to isolate the channel to a single channel. Of course, if you wanted to provide multiple channels, say for different repositories, you can configure that as well. But in this case, we're going to keep things simple and post all updates to a single Slack channel. And an app level token, this is used for socket mode. Once you've enabled socket mode in your application, you can grab it from the UI as well. Like I mentioned, I provided a Slack app manifest that you can go ahead and borrow from to use for creating your app. You can change the name of it, display name, things like that to suit your own needs. Here is our triage agent. So here we have instructions on how the agent should behave, as well as what it has access to. So like I mentioned, I'm using OpenAI GPT 5.2 for this model, and we have a temperature set to 0.1. And then we have a couple of tools. One is the get-dependency-PR, and the other is get-release notes. And from there, we've instantiated a new memory instance so that our agent has some memory context when we're conversating with it. We set up our channels to connect to Slack itself. Of course, you can use any type of channel that Mastra supports, but in this example, we're using Slack. The next thing we can do is take a look at our get-dependency-PR tool. So here we take a couple of inputs on line 13. The input schema is going to be the repo that we're fetching from and the PR number that we want to fetch. The output schema is going to be recognized, whether that means we've actually found a PR that follows Dependabot conventions, whether it's been grouped for multi-dependency updates, which Dependabot also supports, what the dependency is, what the ecosystem is. For example, in our case for Ruby, it is bundler, the from version, so the version it was at prior to the update, the to version, where it's going, the PR URL, the PR body, which will have the description but truncated, and then files that were changed as part of it. So if we take a look at the body itself, we go ahead and we use the GitHub API. In the repo, I have a small library for GitHub to interface with the GitHub API, and we use that to actually fetch the pull requests, list what files there are, and we're going to parse the Dependabot PR itself. So from there, we parse that out and pass that back. Before we move on, let's take a look at our workflow itself. So like I said earlier, the Mastra workflow is going to be the core piece of this whole system. The workflow is going to work in a step order to actually do the triage workflow with our agent. So it's going to be made up of multiple steps. The triage step, which goes ahead and reads the PR and its release notes to return the structured verdict. So we can see here, we get our agent, the triage agent. We generate a new thread ID so that we have that unique memory scope per thread or per run. And we get a result by calling agent.generate, and we tell it to triage the pull request with the input data PR number and the repo. And we give it a fresh thread per run with the memory. So we've gone ahead and we configure the thread with an ID of the thread ID that we generated earlier, and we give it a title, triage, the input repo, as well as the PR number. From there, we've assigned the resource to be the input data repo. So the repo name itself is the resource. So every memory entry can be scoped to a specific resource. In this case, we are scoping it to the PR itself, or the repo itself, actually. And we've defined some structured output, which is the verdict schema of what we're going to return. So once the agent comes back with a generation, we'll also pass it to enforce citation rule. So here's where we do a little bit of a deterministic check on what was sent and make sure that it is valid. So if for some reason the verdict didn't match what we got in the result object, we're going to go ahead and just log that out along with some details about what happened. And from there, we return the verdict, the thread ID, and the input data that was provided to us. The next step is the post card step. Here's where we take that verdict that we got and actually generate a Slack response or Slack message in a new thread for us to go ahead and review. We're going to use the channels SDK to actually do this, and we're going to send that to the channel that we specified in our .env. Then we go ahead and we use render triage card. So that's going to go ahead and try to actually render the verdict from the chat SDK that Mastra uses behind the scenes for channels. We can take a quick look at what that looks like here. So the render triage card takes the verdict and generates a label. So we use a different label based off what kind of verdict it is. From there, we generate some blocks in Slack, and we generate the message itself. So all this is doing is taking what we have and what we've gotten and formatting it in a way that looks nice inside of Slack for us to easily be able to interface with it and read it. If we go down to the bottom, we can take a look at the triage workflow itself. Here we have a workflow. Again, it has its description: read only Dependabot Triage, fetch PR, read release notes, and post a recommendation card. It's broken up into a few steps. One is the triage step. The next is the postcard step, and then we're done. So let's take a look at what this looks like in practice. Here in Slack is a PR update that came through via webhook and went to my factory agent. So we can see that it had the Kamal update for Rails, and the dependency went from 2.11 to 2.12. The risk is noted as moderate. It also reports back to this is a minor bug, includes a revert and a change handling of an existing restart option, which can change deploy runtime behavior without any code changes. Have a maintainer confirm current restart related configuration and expected behavior before merging. We can also see the link to the actual release where this was done. And we have a quick card link here to the actual PR in my application if I want to jump to it. Now, the interesting thing here is that we don't have necessarily in the codex version is I can actually interact with my agent and ask it questions. So for example, here I said, why hold? And it says hold because the 2.12 notes include a behavior change signal. So this is important because it didn't actually go and fetch more information or fetch more data or use the tools again. It actually operated based off of that memory that it has scoped for the thread and is scoped to the resource, which is the GitHub repo itself. So this was all done through Mastra's memory system as well as the channels implementation so that we can communicate with the agent here. So let's take a quick look at Mastra Studio to kind of see what happened as it came through. So here we can see our workflow is broken up into a few different steps: the triage and postcard. We can see the data that came in. The data was simply the repo name and the PR number. After that, the agent ran. And we can see the data that was passed into the next step. So we can see here the verdict that we saw in the channel was hold. The risk class is moderate. It extracted the dependency that was changing. What the from version was 2.11 to 2.12, some citations and a quote, the reasoning for why it decided it was a hold, and the PR URL for this change. You can also see our thread ID for the triage right here. If we go look at the traces for this, we can see a few things. First, let's start at the triage workflow itself. We can see it started. The input step processor for the chat channel context, that comes from Mastra channels. And we can see our first tool call, which says get-dependency-PR. So we can see that the agent saw that it needed to fetch the information about this dependency. It passed in the tool args for repo, the Galarza /weft, and the PR number 39. From there, that was the first step. Then it formulated a new tool call, the get release notes tool. This is the tool that actually fetches the release notes from RubyGems to give us the details about the update so that it can use that to actually decide on its termination. So here it called get release notes with the tool input for the dependency called Kamal. The ecosystem is bundler. The from version is 2.1. The to version is 2.2. From here, we can see the output from the tool itself. So it found it. The source was from releases. And we have the changelog inside of it. So the RubyGems API gives us a change notes or changelog that we can actually use to understand what the changes were. So this was all the information that it kind of worked with to make a determination as to what had happened. And lastly, we can see when it calls the step for sending the channel. So next, if we go into the check where I asked it why it was a hold, we can see that it goes ahead and runs through the message history. So this is part of the memory system as well as the Slack channel configuration. That's the first station in our software factory. In the next video, we'll give the agent access to the codebase itself via Mastra workspaces. It'll work inside the repo directly, tackling small changes as part of the Dependabot workflow. If you want to follow the rest of the build, subscribe and turn on notifications. I'll be adding a new station in every episode. And if you're a team that needs help building with Mastra, there's a link in the description below. Let's chat. Thanks for watching, and I'll see you in the next one.